So this is the start of our G1, G2 outcome. We're talking about a lot of geometry, so we're going to do lots of things with lines and triangles, properties of angles, doing some proofs. So let's first explore some of the different types of lines that we can have. So one of the definitions that you will need to know is what a transversal line is. So the definition of that is that it's a line that intersects two or more other lines at some point on that line. So I draw one line and I call it line 1. I'm going to highlight line 1 in yellow. I'm going to draw another line called line 2. I'm going to highlight that line in orange. And then coming in with a negative slope, I'm going to draw another line, which I'm going to call the transversal, and it intersects line 1 and line 2. Okay? So now what I'm going to do is I'm going to just focus on naming some angles. So the angle from here to here, I'm going to call that angle A. So from here to here, we're going to call that A degrees. From line 2 to the transversal, we're going to call that angle Y degrees. From the transversal to line 2 coming back up, we're going to call that X degrees. And then from line 2 back to the transversal, we're going to call that B degrees. So let's see what we can figure out about these angles. So one of the first rules I'm going to teach you is called, what I call it is the straight line rule, or the 180 degree rule, because what it does is it says that if I have a straight line, I draw a straight line, and I start on one end of the line and go all the way around forming an angle, that angle has a value of 180 degrees. So in my above diagram, if I look at what angles were formed, angle X plus Y are kind of right beside each other below line 2 and where the transversal is intersecting, and X plus Y sits on a line, and so therefore angle X plus angle Y has to add up to 180 degrees. Angle A plus Y sits on the transversal going through line 2 like this, and so angle A degrees plus Y degrees would add up to 180 degrees. A and B sit above line 2, and then the transversal connects and breaks that into two pieces. So there's B here and A here, so both A and B lie on a straight line, so we can say that A plus B is 180 degrees. And then B plus X kind of lie on the left side of the transversal on line 2. So B plus X is 180 degrees. You're going to notice that if I draw line 2 in all three of these examples, there's line 2 drawn in green, and the line is being broken into sort of two parts because of the transversal. So both those parts have to add up to 180 degrees. So let's look at example 1. It says find the value of X. We're going to be working in degrees, shown in the diagram below. So in the diagram, there's a straight line, and then there's a transversal breaking that line into sort of two parts. So I know that X degrees plus 113 degrees has to equal 180 degrees, and that's coming from the 180 rule. We lie on a straight line, so the angle for that line has to be 180. It's broken into two parts. So we're going to ask ourselves, how are we going to isolate for X? I'm going to subtract 113 degrees on both sides. So 180 degrees minus 113 degrees is 67 degrees. So angle X is 67 degrees. But hopefully this should make sense, because if I start on one end of the line and I draw kind of a half a circle all the way till I get to the other end of the line, we know that that forms 180 degrees. Now we're going to go through and talk about another two new terminology. So we're going to talk about what a supplementary angle is versus a complementary angle. And so this table that I provided shows the difference. So supplementary angles are what I exactly call the 180 rule. And complementary angles, we can call it the 90 rule. So I'm trying to use more familiar names for you guys instead of using supplementary and complementary all the time, because if I say 180 rule, that might trigger you to remember that the angles have to add up to 180 degrees. When I say the word 90 degree rule, then you have to think that the angles add up to 90 degrees. So complementary angles are the 90 degree rule, supplementary angles are the 180 rule. So supplementary angles is what we just did in the example above. We have a line that's kind of horizontal, and that line is kind of cut by another line, not all the way through, but kind of at the line, and then draw a line up. That line has two sections being formed. We're going to call the left section angle A, and then the right section that's being formed, we're going to call it angle B. Because we're working with straight lines, we know that A plus B has to be 180 degrees, just like I summarized above. Now, complementary angles, we know that that has to be 90 degrees. One way you can help yourself remember that is C comes in the alphabet before S, and 90 degrees is a smaller number compared to 180. So when you think of C, you need to think of the smaller number. So complementary means 90 degrees, supplementary means 180 degrees. So complementary angles are angles that add up to 90 degrees. So somewhere on the paper, they need to show you that little square that helps you remember that an angle that's formed is 90 degrees in the corner. So if I know that one section of a line, like I've drawn one line vertical and one line exactly horizontal, on one angle of that T, we know it's 90 degrees, which means all those sections of the T need to be 90 degrees. So essentially, this section needs to be 90, this next section needs to be 90, and this last section needs to be 90. So literally a T, each part of the T needs to be a 90-degree angle. Then what I do is I take a line that breaks up A and B, not exactly in half. This line does not cut in half. So this line does not cut in half. It doesn't have to, it can, but it does not cut in half. The angles that are there, A can be, say, 30 degrees and B can be 60, but we know the relationship between them is that A plus B has to work out to 90 degrees. So let's look at example 2. So use the diagram shown below to predict the measures of as many angles as you can in the diagram. Justify each of your predictions. So as we're working through this example, the justification would involve you writing sort of like a two-column proof. On the one side, we would write a statement, and on the other side, we would write why we think that statement is true. Us teachers would like you to present your answers like this all the time, just to get you used to kind of the proof technique. So what I'm going to say is I'm going to look at this. In this example, it's almost like that previous example I just mentioned with a T, but instead of having a vertical line, I have two diagonal lines intersecting each other, almost like an X. And in those lines intersecting, we sort of have four sections being formed. I'm going to call the top section 140 degrees. I'm going to call the right section A degrees. I'm going to call the bottom section B degrees. And I'm going to call the left section C degrees. I'm interested in finding each one of those values for A, B, and C. Now, what do I know here? I know that the one diagonal is a line, and so I know that there's something called the 180 rule. That line is being broken apart by two angles, the 140 and the A. So what I'm going to do is I'm going to say that A equals 40 degrees, and I know that because I know that A degrees plus 140 degrees has to equal 180 degrees. And the reason for that is the straight line rule. So you can justify it with straight line rule. You can justify it with 180 degree rule. Or you can use the proper name for it is the larger number, so we know that that has to be later in the alphabet, so we can call them supplementary angles. Now, on your assignment, we will make you do the fancy terminology at least once, just to make sure you know it. But what you want to really think about is making sure that you try to think about the familiar names of what these are called, because in the future they're not going to call it the 180-degree rule, they're going to call it supplementary angles. Okay, in this example I want to isolate for A, so I'm going to subtract 140 degrees from both sides. So A degrees equals 180 minus 140 degrees would give me 40 degrees. So my statement is that A is 40 degrees, and then the justification is just the work I do to show why that is 40 degrees. So now in my diagram of that X, I'm going to write that A, which was the right-hand angle that was formed, is 40 degrees. Now I'm going to say, well, what is B equal to? Well, I know that if I look at the other part of the X, it's another straight line. So I know that B plus A, which we just found out, has to equal 180 degrees. From the previous step, I solved for A, which was 40 degrees, equals 180. I want to isolate for B, so I'm going to subtract 40 degrees from each side. And I'm going to get that B is equal to 180 minus 40 degrees, which is 140 degrees. I'm going to call this again the straight line rule. Okay, or you can justify it with the 180-degree rule, or you can use the proper terminology and call it supplementary. I would accept any one of these from you guys because, again, sometimes remembering a familiar name is better than remembering the fancy name for it. So B is 140 degrees. Now, again, I'm going to look at C. So I'm going to look at the yellow line, which was the left diagonal of the X, the one with the negative slope. I know that angle B plus C lie on a straight line, so therefore it has to equal 180 degrees. So B I just worked out to be 140 degrees, plus C degrees is 180 degrees. I'm going to isolate for C by subtracting 140 degrees from each side. So my angle C is equal to 180 minus 140, which is 40 degrees. And again, we can justify that with the straight line rule, the 180 rule, or we can use the proper name is that B and C are called supplementary angles because they add up to 180 degrees. Okay, and that's sort of the end of our first kind of justification. Now, because the justification involves numbers, this is not really a proof, but it just shows how we're getting the answers. In some of the questions, if I, instead of using the word justify, if I said prove, now all of a sudden we have to have letters and variables and no numbers in there when we're doing proofs. And we will look at some of those, but those are sort of the way exemplary level problems of the section. More terminology. This unit again has a lot of terminology. Interior versus exterior angles. So when I think of the word interior angles and I think of the word interior, I want to think of the word inside. When I think of the word exterior angles, I want to think of the word outside. So when I form an interior angle with a transversal, it's the stuff that sort of lies on the inside of the lines that you're working with. And if I'm looking at exterior angles, I'm looking at the lines that, or the angles that are formed on the outside of the lines. So in this example, for the interior section, I have two lines. Now in these lines, I've drawn two horizontal lines, and they're not even strictly horizontal. One can be tilted with some small slope, big slope, doesn't matter. The other one can be tilted. They can intersect, that doesn't matter. So I have two lines that look like they'll intersect, but they don't necessarily intersect at this moment. And I've labeled each of the lines line 1. So the top one I label line 1, the bottom one I label line 2, and then I take a non-horizontal line and I cut those two lines. So this line that intersects those at one point is called the transversal, if I can spell it correctly. Transversal. So this transversal forms 8 angles. So there's 4 angles being formed with line 1, and there's another 4 angles being formed with line 2. So each line forms 4 angles with the transversal, the left, right on the top and the left, right on the bottom. And then for line 2, there's left, right on the top, left, right on the bottom. So my interior angles would be the angle A and B, which lie below line 1, and lines C and D, which lie above line 2. So those are called our interior angles. And then on the diagram to the right, I label E and F, which lie on top of line 1, and then line G and H, which lie on the bottom of line 2. Now another difference that I have in the 2 diagrams is the diagram on the left for interior angles, I have my line 1 and my line 2, and they are not parallel to one another. But my diagram on the right, I have line 1 and line 2, but I make them parallel, and I show that by showing a little arrow on line 1 and the same arrow on line 2. That tells me that those lines are parallel. Then I take a transversal, which is non-horizontal, and I cut through both those lines. And that transversal has a negative slope in the exterior example, and in the interior example, that transversal has a positive slope. That transversal can intersect those lines in any way we want. Now, the angles that are formed above line 1 and below line 2 sit sort of on the outside of line 1 and out line 2, so we call those exterior angles. Okay. Now, this is the part where things get a little bit tricky, is now we're going to talk about alternate interior, alternate exterior. So when I think of the word alternate, I think of the word opposite. So I'm looking at sort of the opposites of the angles that are being formed. So you can kind of look, A and D are sort of opposites of one another, and B and C are sort of opposites of one another. So those are called opposite interior angles because they lie below and above line 1 and line 2 respectively. And then when I look at E, F, G, H, E and H are kind of opposite, and F and G are kind of like opposite, so we call those alternate exterior angles. So there's alternate interior, alternate exterior, and then interior and exterior angles. Now, if the lines are parallel, we can make a conclusion that those opposite alternate exteriors or alternate interiors have to be equal. So in example 2, in the alternate exterior example case, the E has to equal the H, those were alternate to one another, and the F have to equal G because those are alternate to one another, but also because the lines are parallel. That's the key. Okay? In my example, the lines aren't parallel. Now, another way you can think about this is sort of like a Z rule. I'm going to draw sort of a weirdly shaped Z. And so you can see E and H are kind of on the opposite parts of the Z, and F and G are on the opposite. If my line 1 and line 2 were the same, I could make this interior and that interior the same. I could also make this interior and that interior the same. So the alternate exteriors or alternate interiors will be the same when you have parallel lines. But if you don't have parallel lines, you cannot make that assumption. So let's talk about corresponding angles now. More terminology that we need to know. Literally, kind of today's lesson focuses on a lot of the terminology we're going to use. So with corresponding angles, we need to have 2 lines. So I draw one sort of horizontal looking line with a somewhat negative slope. I draw line 2. In my example, I've drawn it kind of strictly horizontal. And then I take the transversal that cuts through line 1 and line 2. And again, we form 8 angles, okay? So with line 1 and the transversal, 4 angles are being formed. The top left, the top right, the bottom left, and the bottom right. And then when that transversal cuts through line 2, we have another 4 angles being formed. The E on the top left, the F on the top right, the G on the bottom left, and the H on the bottom right. So now what we want to do is I'm going to highlight those 4 angles a different color. So A is angle on the top left, B is top right, C is bottom left, D is bottom right, and I'll use a different color for D. So I just highlight those 4 different colors. Now what I want to do when the transversal cuts through line 2 is I want to use the exact same 4 colors. Top left is orange, top right I made red, bottom left I made green, bottom right I made blue. So the stuff that I colored in are called corresponding angles. So the orange with the orange are the same. So the top left of line 1 and the top left of line 2, which I've labeled A and E, are called corresponding angles. The top right of line 1 and the top right of line 2, which I've labeled B and F, are the same, or not the same, they're corresponding. The bottom left of line 1 and the bottom left of line 2, I've labeled them C and G. They're both highlighted in green. Those are corresponding. And D and H, which are the bottom right of each line, are colored in blue. Those are corresponding. So we give the name corresponding to the angles that sort of sit in the same position on both lines. Now again, another key idea is if the lines are parallel, then those corresponding angles are going to be equal. Okay, so this is a key idea. There will be an assignment question later that uses this key idea that says, are the lines parallel? If the lines are parallel, the corresponding angles will be equal. So kind of keep this statement in mind. Kind of put a star beside it because that will come up on your assessment or / assignment that you've been given for this section. So let's go through. Now the first example here, it says example 3. This is the first proof we're doing. So when we did conjectures, we did proofs. This is the first proof in this triangle section that we're using. And because I'm proving it with variables and numbers and no variables or numbers that are not specifically defined, I'm actually proving it using deductive reasoning. In the example above, say example where we found A, B, and C to be 40, 140, and 40, because I got very specific answers, that's sort of just working out an example. This is the actual first example of a proof. So what I want to do is I know that the conjecture that they made is when a transversal intersects a pair of parallel lines, those alternate lines the alternate interior angles will be equal. So what I'm going to do is I'm going to take one color to highlight the condition of my sentence, which is the transversal intersecting a pair of parallel lines. That's important. And then the conclusion to that statement is that the interior angles are equal. So that's what I need to show. So let's start with what we're given. So I'm going to label my lines line 1 and line 2, which are both strictly horizontal. Those lines are parallel because that's given in the question. They've indicated that to you by putting a little arrow on the line 1 and line 2, indicating they're the same. So what I'm going to say first in my statement is angle 1, or well, let's just say here actually, line 1 equals or is parallel, or I'll write that here. Line 1 is parallel to line 2. And then under the justification, we're going to write that that information was given to us. Okay, so now because line 1 and line 2 are there, they've labeled 4 angles for me off of each line, but they didn't number all of them. But I'm going to color in top left of both corresponding orange, top right of both corresponding red, bottom left I'm going to highlight green on both, and bottom right of both lines I'm going to label in blue. So I have 4 colors in my diagram, 4 that lie with line 1 and the transversal, and 4 that lie with line 2 and the transversal. Now because I already know that line 1 is parallel to line 2, I'm going to say angle number 1 is equal to angle number 2. And the reason for that is that corresponding, that's the name of the colors I've colored in, the two red ones, corresponding angles are equal on parallel lines. So that's the reason that number 1 and number 2 are equal. Okay, they both lie on the top right when the transversal cuts them. Now what I'm going to look at is the transversal line itself. I'm going to highlight in yellow. Now you're going to notice that on the top, angle 1 and angle 4 are being formed using the straight line rule. So I'm going to say angle 1 plus angle 4 has to add up to 180 degrees. And the reason for that is the 180 rule, or you can use the proper terminology that the angles are supplementary. So I'm going to call them supplementary angles. So I also know that angle 3 and 4 will be equal to 180 when you add them up for the same reason. Okay? So now we're going to sort of do something called a transitive property. So because both of these 180s are exactly the same, I highlight both the 180s, and then if I highlight angle 1 and 4 and 3 and 4, the yellows are equal and the greens are equal. So that tells me that angle 1 is equal to angle 3. Okay, and we can call that transitive property from previous step. So I literally make the greens equal to each other and the yellows equal. So the greens being equal mean angle 1 plus angle 4 has to equal angle 3 plus angle 4. And then if I subtract angle 4 from both sides, I get angle 1 equals angle 3. So that's my result from there. But likewise, angle 2 also has to equal 3 because from step 1, angle 1 had to equal angle 2. So if angle 1 is equal to 3, angle 2 also has to equal 3. So now I look at it, I got angle 1 is equal to angle 2, those are corresponding angles, and angle 1 is equal to angle 3. So I'm going to say that angle 1 equals angle 3, angle 2 equals angle 3, and so I'm going to say since these angles are equal, this means that the alternate interior angles are equal, and then I'm done. So angle 1 equals angle 3 and angle 2 equals angle 3. So if I come back, I can draw sort of that Z rule, which is the alternate interior. So angle 3 is an interior, angle 2 is an interior, and if I draw my Z rule out, those opposite interiors or alternate interiors are the same because we just proved that, which is what we were trying to prove in the question. I'm going to highlight that conclusion in the question, and then I'm done my statement. Okay. Now in the next example, there's variables involved, but there's also numbers I've given. So we just need to provide a justification, which is going to be presented in the proof-like format. So let's look at this. One key information I'm given is that I've drawn line 1 and line 2 to be parallel to one another. They've indicated that with those little arrows on the line. And I also know that so there's sort of 4 lines happening. There's line 1 that's parallel to line 2, and then there's sort of 2 transversals coming in, which I'll call line 3 and line 4. Now line 3 and line 4 are also equal because they indicate that through these 2 barred lines on the lines themselves. So now let's try to figure out what does A equal, what does B equal, what does C equal, and so forth. Now, because my lines are parallel, what you want to think about is your Z rule. So I'm going to draw my little Z out with my parallel lines that are given to me. So I'm going to kind of draw like a little Z. The Z can be backwards or forwards. So B and 110 have to be equal to each other because they're alternate exterior angles. So angle B is equal to 110 degrees, and I'm going to say alternate exterior angles are equal. And then I'm also going to put a note that there were parallel lines that formed it. So when you're thinking of parallel lines, I want you to automatically think of the Z rule, and that's like forming a Z either in the forwards direction or the backwards direction. Okay, now what I'm going to do is I know that B is 110 degrees. So now I'm going to look at the variable X. So I know that variable X and the number 110 lie on a straight line, which I'm going to highlight in orange. So that straight line is the straight line rule. So 110 plus X has to equal 180 degrees. You can call it the straight line rule or the 180 rule. I'm also going to write supplementary angles just to remind you of the fancy name. If I isolate for X by subtracting 110 on both sides, I get X is equal to 70 degrees, which is 180 minus 110 degrees. So I get that X is 70 degrees. Okay, so now that X is 70 degrees, angle X and A also fall on a straight line. So I'm just going to draw that straight line in blue. So I'm going to write angle A is equal to 110 degrees. I kind of worked that out in my head, but I know that X plus A equals 180. X is 70 degrees, so 70 plus A equals 180. I subtract 70 on both sides. So minus 70 minus 70. So A is equal to 110 degrees. And again, you can use the justification that they are supplementary angles if you'd like to use the fancy one, or you can call it the straight line rule or the 180 rule. So supplementary angles. Now we're left to find C and D. Now C and D are lying on parallel lines. So what I'm going to do is if I label my corresponding angle, so B goes with the top left. The other side of B, the top right of line 3 and the top right of line 1 would be the same. The bottom left and the bottom left, so X has to equal C. So I'm going to say X equals C. So C has to equal 70 degrees. And we're going to label that with corresponding angles. Corresponding angles on parallel lines are equal. Okay, and then angle D is also, I'm going to label the last one blue. So angle A matches the bottom left. Now if I do another set of corresponding lines on being formed with line 2 and line 4, the top left I've already highlighted yellow. The top right is labeled D. So D is the same as 70 degrees. But if you want to look at D, because we have a whole bunch of parallel lines here, you also want to look at the Z rule happening. So angle D is also going to be 70 degrees because of the Z rule. So if I come in with my black pen, I'm going to draw a little Z rule happening. So 70 and D are alternate interior angles on parallel lines, and they're opposites or like alternate, so they're going to be equal. So I'm going to say D is equal to 70 degrees. You can call it the Z rule, which is relating parallel lines, or you can call it alternate interior angles are equal. Okay, so we're going to stop there. Now, before I stop this video, there are going to be 3 files you'll be given. Those 3 files will be related to parallel lines. There's going to be an easy file, which talks about the language and the terminology, so you'll work through that. There'll be a medium activity, which starts to do variables related to alternate interiors, parallel lines, and so forth. And then there's a hard one with more variables and more lines. So all of these activities will be posted under the content section of our D2L shell. And you can practice those, and either the solutions will be posted or a video will be made on those solutions. The other thing you can also do is work on your G1, G2 take-home assessment that will be due at the end of this unit. And you can work on the questions that relate to the topics we just covered.